NEET 2025 didn't go as planned.
535 मार्क्स, बस थोड़े से मार्क्स से रह गई। बायोलॉजी ठीक था, केमिस्ट्री भी, पर फिजिक्स वो फिसल गया। इस बार पढ़ाई नहीं, तैयारी करो, वो भी स्मार्ट तरीके से, क्योंकि इन्फिनिटी लर्न लाए हैं अट्रेया, इंडियाज मोस्ट पावरफुल नीट रिपीटर्स प्रोग्राम विद P²CB, जिससे फिजिक्स पे होगा डबल फोकस।
Don't just make it your last try, make it your best one yet. Join Infinity Learn today.
Hi, good noon my dear students. Welcome to one more amazing session from Infinity Land. This is Suresh, Faculty of Chemistry. How are you all doing my dear students? Hi Rajput, just give me confirmation all students, can you all able to hear me and see me? And today we are going to discuss about thermochemistry, and in the previous class we discussed about the fundamentals of thermodynamics. And we need to enter into the more details about entropy and Gibbs free energy. अगले सेशन में ऐसा करने का कोशिश करता हूँ. And my dear children, today's class is about thermochemistry. Thermochemistry is related to grade 11 students and grade 11 syllabus. So we can say this session for today right now is very helpful for those preparing for 11th standard as well as the 12th standard and who are in preparing for NEET 2026 as a droppers के लिए भी अच्छा होगा. And dear students, based on this thermochemistry, I can say definitely one question means 4 marks will be in your pocket at the end of the session. And it is a really important, and most of the questions from thermochemistry can be handled by using the firm definition. If you have a very good command on the definition, you can solve theoretically and chota mota numericals bhi kar sakta. And today's class, get ready, theory as well as multiple choice questions we can do it. Ready for that everybody? Dear children, let us see, before going for the thermochemistry, let us go for a little promotion. And hi says bro, hi. Can you hear me? Just give me. Can you hear me? Right. Those who are online, please like the session and share your this session with your friends. In लोगों को भी फायदा होना चाहिए, and subscribe to NEET Infinity Land channel. So I want to see when you when you press this like button, I can see the number is changing in front of my screen there. And please like the session. Okay, Sisa bro and Kesh Rajput, hi. How are you? And before going for the thermochemistry, I just want to say the promotion of Atreya program. And the promotion of Atreya program follows like this. Those who did your NEET examination, and congratulations, all the best. And because of some reason, if you are not in a position to just crack your NEET exam, however, you are deserved, all the students are deserved to get this NEET. But here something is missing. So Sri Chaitanya Academy Infinity Learn is introducing Atreya program. In this Atreya program, you can see we are going to transform your status from I didn't do to I will do it. Yes, it is, because we have scientifically generated a new academic program and you can do the best for your NEET. And India's most powerful NEET repeaters program, Atreya Plus. उसमें क्या चीज़ है? We have P²CB. We have a P²CB program. What is this P²CB? Physics is twice a day and chemistry and biology. As you know pretty well, and physics is, if you say biology and chemistry and physics. So biology went well and chemistry is also better, okay, not worst, and come to the physics, it is slap like everybody. And so if I ask a question, which is the difficult subject to you guys? You simply claim this is a physics. So not only you, physics is difficult, and it is for the entire students, it is going to be a difficult subject. So the physics, no more a difficult, and your difficulty level of physics is on us, and we'll be giving you P square CB program, where it is a very good program, and Atreya, it is India's most powerful revolutionizing program for NEET repeaters, and it is very important, and the link is available in the chat box, in the pinned messages, and the description box. You just click it and you can just go through it, and what is the course content is there. Let us see here. And the course structure, the batch commenced May 23, long ago. And if that happens, how do you prepare? Yes, if you enroll, you will be allocated your place in a new batch. So no worries. And the days of the week in the classes, it is from Monday to Saturday. Sunday का छुट्टी है, आप assessment ले सकते हैं, test, part test और periodic test, you can do it. And you can say duration of each class 90 minutes का है, 1 hour 30 minutes. And you have 3 classes per day, and उसमें 2 concept classes होगा, उसमें ये एक practice session होगा. Practice session किसके साथ है ना, faculty के साथ होना. And you see 18 classes per week, उसमें खास बात है double physics practice program, and the practice program double, it is for the physics, and you can do the best. Okay, and dear children, yes, now interactive live classes. So course features interactive live classes by expert faculty, 465 classes in the entire package, so that you won't have that much pressure. And you can say DPPs, 240 DPPs will be reached to you, and dedicated practice classes, 120 practice classes will be there. You see 465 and 120 hours, and this plus this is included in the package, and this indicates the 25% of this. So for every 4 sessions, you will be having roughly more than 1 practice session, so that you will be having a confidence on what you are doing. And also after class, you need not have to find any notes. Revision notes will be automatically reached to you in the PDF format. And the most important point is batch size for the practice class is just 20 to 25. And dear students, it is not 1 in 100 students. And you see in the online platform, hundreds of students are dumped where you have to just watch like a fellow. So here just it is a small batch for the practice session, 20 to 25 students, so that you will be having an opportunity to discuss with the faculty. When you discuss with the faculty, you will understand what is customized doubt resolutions, and you can have a direct talk with the faculty as well, and this helps you a lot to crack the NEET examination, definitely, my dear students. And total 11th and 12th syllabus will be covered like a pro for the NEET examination. Okay, and we are done for the Atreya program, and please click the link, it is available in the description box and the pinned messages also. And you just please like this session and share with your friends, and subscribe to Infinity Land NEET YouTube channel, so that you will understand. So you will be getting updates about when the class can happen and what the class is going to happen. And anyways, once guys you completed NEET, you can just go for the rank of predictor. This is also link is available. And let us talk about the thermochemical equation. And my dear students, let us start. So promo is over, let us directly join into the concept. Ready? Thumbs up and fire emoji in the class. I want to see those students who are online, please like the session. So I want to start thermochemistry. And this particular thermochemistry is very important. It is all about this NEET examination preparation. So whatsoever the competitive examination may be, here thermochemistry talks about the heat lost or heat gained during a chemical reaction. So by using various principles, how much heat is lost and how much heat is gained, we will be technically calculating these things. And if we want to have these sessions, this kind of expert faculty lectures, you need to go to the coaching center and travel a long way, and you just pay a huge amount of money, and you have to spend money. Here in the YouTube channel, we are giving lectures from the expert faculties from the YouTube studios here, and it is absolutely free and you need not have to pay anything, and take a pen and paper and write the noteworthy points. That is going to be super useful to you. Okay, and please like the session. Who are there online, please like the session so that we can start. A thermochemical equation. During a chemical reaction, reactant gives rise to the product, and a balanced chemical equation, an equation which gives all information about the physical state of the reactant and the product, and the state and the phase, and how much heat is gained, how much heat is lost, everything is indicated, is called as a thermochemical equation. In this thermochemical equation, you can have various states of matter and various allotropes of carbon and various phases of the system, and the magnitude of the heat is released and the magnitude of the heat is gained, and this is called thermochemical equation, my dear students. Here in the thermochemical equation, let us say here enthalpy of a reaction can be seen. Let us say A plus B gives rise to C plus D. Okay, and along with this, so it has to be represented its physical state, otherwise it will not be, right? So here let us say X kilojoules of heat is released during this. You can say these are the same thing. Thermochemically you can write A plus B gives rise to C, and the enthalpy change during this process is going to be minus X kilojoules. You see, this is an exothermic process. And if it is the other way, you can say A plus B and X kilojoules, so you are going to get a C. In that, X kilojoules is getting into the reaction, so it is endothermic reaction. System ko फायदा हो रहा है, so this is what is called A plus B gives rise to C, and delta H is going to be plus X kilojoules. Are you getting or not? Plus X kilojoules. So ताकि इसका माइनस क्या दिख रहा है, एक्सो का, प्लस एक्स दिख रहा है, it is endo का. That is very important. Okay, so in the thermochemical equation, you have two types of chemical reactions are there as far as the thermodynamics is concerned. First is endothermic reaction, those reaction which absorb the heat, which take the heat during the reaction is called as an endothermic reaction, and exothermic reaction, the reaction in which the heat is released, is called exothermic reaction. I just maintained here A plus B gives rise C. Delta H is going to be system का फायदा उठ रहा है, so this is called X kilojoules. Let it be the any value, my dear students. Please don't memorize any values. जो भी value चाहिए ये question का हिसाब से ये question data में दिया जाएगा. So don't worry. When you just see the textbook and the answers and solutions, these values कहाँ से उठा के यहाँ पे डाल रहे हैं, so it will be given in the question itself. Don't worry. Okay, just memorize the definition and follow the logic given by the definition, and can give you very good insight for this, right? And exothermic reaction, those reactions which heat is released are called as an exothermic reaction. Those who are online, please like the session. My request, please like the session. So dear students, let us say A plus B gives rise to C. Delta H is going to be, it is a negative X kilojoules. So negative is showing it is an exothermic reaction, positive it is showing it is endothermic reaction. So my intention here, how to calculate this, and there are so many methodologies are there to calculate this, right? So take a pen and paper, write all the noteworthy points. Let us say for a chemical reaction, this is called enthalpy of reaction is equal to sum of the enthalpies of the products minus sum of the enthalpies of the reactants. मान के चलो reactant product दे रहे हैं, reactant gives rise to the product, and how much reactant is there and how much product is there and what about their values is the key point here. and that enthalpy and internal energy is, these are two things. So the enthalpy during a chemical reaction occurs to the breaking and making of the bonds, right? So what is exactly enthalpy and what is exactly internal energy? As you know, internal energy is the sum of all types of energies, potential energy, kinetic energy, rotational energy, जो energy है, that is a constant. You can't directly measure the internal energy because internal energy is a state property. But the change in the internal energy can be calculated. Delta U is equal to U2 minus U1, right beta? And similarly, so what is the enthalpy? In general, internal energy is the heat content of a system at a constant volume, mind it. But in the nature, all the natural processes are taking place against to the atmospheric pressure. So यहाँ पर natural process में pressure constant देख रहे हैं. So that we need one more thermodynamic state property, that is enthalpy. So enthalpy is equal to internal energy plus work done, right? So work done, generally you take PV work done. So PV is equal to nRT, P delta V is equal to delta nRT. So that here you can see this is a very, very important. Enthalpy change is equal to internal energy change plus delta nRT. So what is delta n here? I want to hear from you, my dear students. Hi, those who are in online, please let me know what is delta n there. So it is a live interactive session so that we can have a discussion between you and me. And if you have any genuine doubts, you can use the chat box. You can ask, a senior faculty is standing in front of you and asking requesting you to ask a doubt. So it is a golden opportunity, my dear guys. You can use the chat box, you can ask a question. Dear students, here delta n is indicating here, delta n is indicating in the gaseous state is equal to sum of the number of gaseous systems of the products minus sum of the number of gaseous moles of the reactants. That's very important. So you will be given internal energy for a given reaction and you are asked to calculate enthalpy change, or you can give enthalpy change, you can calculate internal energy change. So this is all applications of first law of thermodynamics, right? So what is first law of thermodynamics? Dear students who are online, please, those who are in online, please let me know what is the first law of thermodynamics. Rajput and Shish bro, and if you are actively participating in the chart, we can have a discussion. My dear students, it's a super important topic. Right from scratch level I am discussing this, so that is going to give you a very good insight. And also this particular session has a lot of numericals and I'll give you the tricks to calculate the numericals. So dear students, here let us take three cases, bachcho, three cases. If delta n is equal to 0, if delta n is equal to 0, क्या करना? If delta n is greater than 0, क्या करना? If delta n is equal to less than 0, क्या करना? These are the three different conditions. So let us apply. This is delta h is equal to delta u plus delta nRT. अगर 0 माने है तो क्या होगा? Delta h equal to delta u, दोनों बराबर होना है. उसमें क्या एग्जाम्पल देना? Super Arnav, thank you very much. You want to love to study with me. Thank you and please like the session. And इसके लिए कुछ एग्जाम्पल देना चाहता हूँ आपके लिए बच्चों. If H2 gas combined with I2 gas gives rise HI, 2HI. So उसमें this is also gas. Delta n is equal to 2 minus इसका 1 mole, इसका 1 mole, 1 plus 1 is equal to 0, ताकि इसका delta n is equal to 0, ये reaction को delta u is equal to delta h. ठीक है बेटा? Okay. Now QWERTY bro, hello. So follow my lessons, okay? And let us say if delta n is greater than 0, So if delta n is greater than 0, I want to take the PCl5 in the gaseous state, and if it is dissociated to gives rise to PCl3 and Cl2 in the gaseous state. Okay, उसमें क्या होगा? So delta n is equal to product में 1 plus 1 होगा and reactant में 1 होगा. So it is going to be plus 1. Delta n plus 1 होगा क्या होगा? Delta H is greater than delta U. Delta U stands here internal energy change. Delta H is equal to enthalpy change. Okay, बच्चों, and delta n, let us take a less than 0 example. So मेरे पास एक example है N2 gas plus 3H2 gas gives rise to NH3 gas. Okay, so delta n is equal to, इसमें 2 है, minus वन प्लस 3. सो डेल्टा एन आपको मिलेगा -2. जब डेल्टा एन माइनस होगा तो डेल्टा एच is less than delta U. Okay, you understand this and this and this. So these are the 3 variants of the discussion you need to have, right? In the examination you will be given delta H, a reaction will be given, you can calculate delta U, or delta U will be given, you can calculate delta H. These are the methodologies you can have. And the key point is to calculate delta N. Delta N is the difference between sum of the number of gaseous products minus sum of the number of gaseous moles of the reactant. है ना? Yes. हाँ बेटा Yadav, Abhinav Yadav, hi. I think you are regularly attending my class. Am I right? How are you doing, beta? Moving ahead, any doubt as far as this slide is concerned, please use the chat box and let me know. Please, everybody who are online, please like the button. When you like the button, session का जोश बढ़ जाता है बेटा. Please click the like button. ठीक है? Now, yes, please, any doubt? Okay, moving ahead here, enthalpy of the reaction. So during a chemical reaction, the reactant is going to be converted into the product. So when the reactant is converted into the product, how much heat is changed? That is called as heat of a reaction, or enthalpy of a reaction, is equal to sum of the heat of the products minus sum of the heat of a reaction. If the enthalpy of a reaction is positive, is called endothermic reaction. If enthalpy of a reaction is negative, it is exothermic reaction. What if enthalpy of a reaction is equal to 0? I want to know. Okay, Kaushik Kumar, what if enthalpy of reaction is going to be 0? I want to know. Good afternoon, Kaushik Kumar. Yeah. So what if delta H of the reaction is going to be 0? Such reactions are going to be thermoneutral reactions, mind it. So it's a weird definition. Okay, moving ahead, enthalpy of reaction. Enthalpy change can be calculated all the reactions if sometimes called heat of a reaction. You have various types of heat of a reactions. Let us discuss technically. And you can see heat of reaction is equal to sum of the enthalpies of the product minus sum of the enthalpies of the reactant. And in that first version, so enthalpy of reaction can be enthalpy of formation. So it could be for enthalpy of combustion. Okay, it could be enthalpy of neutralization. It could be for enthalpy of solution, or bond dissociation energy, or enthalpy of solution. So enthalpy of reaction is of various types. Let us talk about enthalpy of formation. Enthalpy of formation is the enthalpy change when 1 mole of the substance is formed from its constituent elemental reactant. Mind it, the reactant supposed to be an elemental state, but not from other compound. Okay, so this is what is called as a enthalpy. Carbon, which is in the graphite, when it is combined with oxygen, which is the gas, and gives rise to carbon dioxide, which is the gas, and delta H is equal to minus 393 kilojoules. So this value indicates the enthalpy of formation of carbon dioxide. Enthalpy of formation of carbon dioxide is going to minus 393 kilojoules. So if I want to say calcium carbonate on heating gives rise calcium oxide plus carbon dioxide, and this reaction do not indicate the formation of carbon dioxide, enthalpy of formation of carbon dioxide. That's very very important, because जिस reaction ये reaction में carbon dioxide form हो रहा है, लेकिन a carbon dioxide forming from other compound, but here carbon dioxide is formed from elemental substance, carbon, graphite and oxygen. So you want to say the enthalpy of formation of a compound will be given in the examination. Whatsoever examination, चाहे आप board को prepare कर रहा हूँ, you are preparing for NEET, जो भी examination के लिए, लेकिन okay, Kaushik, now let us see here. It is mentioned that enthalpy of formation of elemental substance is 0. You can see enthalpy of formation of oxygen gas is 0. It is taken arbitrarily like this. ख्याल में रखो, ये काम बहुत आ जाएगा. So enthalpy of formation carbon graphite का 0 होगा, carbon diamond का नहीं 0 होगा, graphite नहीं, carbon diamond is not 0. Okay, graphite is 0. Okay, and enthalpy of formation of a bromine liquid is 0, chlorine gas is 0, oxygen gas is 0, sulfur it has different allotropes, usme rhombic sulfur is taken as a 0, and you have the enthalpy of white phosphorus is taken as a 0, and it is not a black phosphorus or not a red phosphorus. Okay, and enthalpy of formation of H plus in aqueous is taken as a 0 beta, and this is a noteworthy points. Everybody take this, and directly you can do. Handling thermochemistry is going to be so easy when you stick to these fundamentals. Okay, when you stick to this fundamental, it is going to be so easy. Okay, understand? Okay, is there any disturbance from the class? You can see any side sounds, please let me know so that I can handle the situation. Is my voice is okay? Any disturbance from my end? Kaushik Kumar, Arnav, and anybody? Abhinav Yadav, please mention. And talking about the details about here, so enthalpy of combustion, jo enthalpy of reaction, it could be enthalpy of formation or it could be enthalpy of combustion. So the heat, generally combustion exothermic hota hai, combustion exothermic hota hai. So it is supposed to be exothermic. Whenever it is exothermic, iska delta H is supposed to be negative hona hai. And enthalpy of combustion is the amount of heat released when 1 mole of substance is completely subjected for combustion in excess of oxygen. So CH4 plus oxygen gives us CO2 plus H2O, delta H is going to be minus 890 kilojoules. Okay, so when you look at this, this is a definition and this is an example. In this example, one value is given. Don't worry about these values. Okay, it will be given in the examination. You know one thing, those who are preparing for NEET examination, especially like biology, and especially their fear of, when you look at the number, na, you will get a kind of psychological fear about the numbers. Don't worry. I will tell you the simple tricks that you can handle the situation so nicely. है ना madam? Ready? And this is called enthalpy of combustion. हमेशा ये exothermic होता है. Now, like talking about enthalpy of solution, and enthalpy of combustion gives rise very good insight, and as well as enthalpy of formation also gives a very good insight. What is the insight? I'll tell you. Here, enthalpy of a reaction is going to give you sum of enthalpy of formation, standard enthalpy of formation of the products minus sum of the enthalpy of formation of the reactants. Okay. Now, let us talk about enthalpy of combustion. During a reaction, generally the compounds are subjected to combustion. So, what happens during a reaction, old bonds are broken and new bonds are formed. So, that if you take the difference between these two, you can calculate the bond energies or bond enthalpies also, right? Like that you just please follow the definition and the logics. So, let us talk about the enthalpy of a solution. So, what is a master in thermochemistry in minutes? So, it all depends upon the definition I am telling you. So, here it is the heat released or absorbed when 1 mole of a compound dissolved in excess of solvent. Yes, most of the solvents, when you dissolve it, okay, the salt is going to break into its constituent ions, so that you need to introduce some energy to separate them. Okay, so that the energy that is responsible to bind these two ions in the salt is going to be the lattice energy. Yeah, Sana Rahman, hi, how are you? Sana Rahman, hi, how are you? Abhinav Yadav, please come on. Here, when these two are separated, you are going to give some energy that is called as a hydration energy for the water. And when they bond, it is going to give the lattice energy. So, a salt will have two parameters, one is the lattice energy, another one is the hydration energy. So, the lattice energy is the energy that released when 1 mole of ionic solid is formed from its constituent gaseous ions. Then hydration energy kya hoga? The amount of energy released when 1 mole of the ions is dissolved in large excess of solvent. So, the simple trick I can give you, no problem, FF option, I think Devanshu, right, your name? Your name is Devanshu, right? Okay, so please like the session, Sana Rahman and Abhinav Yadav and Devanshu. So, whatever your weird name, it is there. When you attend my classes on the regular basis, I can remember you, name, your performance, and you are going to be my favorite students. Ready for that? Just a thumbs up. Yes. Dear students, please like the sessions. Who are there in the session, please like the session. So, I am back to the lattice energy and hydration energy. Mind it, simple trick. If hydration energy is greater than lattice energy, that salt is soluble in the water. If lattice energy is greater than hydration energy, is not soluble. Okay, we'll do more about these lattice energies and hydration energy in the more upcoming classes. So, let's talk about here enthalpy of solution. Here, when magnesium sulfate is a solid, is dissolved in large excess of water, it is going to be converted into magnesium 2 plus and sulfate 2 minus. Okay, Devesh, I don't understand. Kaushik Kumar, right. So, here the amount of energy that is released, it is practically, it experimentally, it is observed like that. I want to show you this is called enthalpy of solution. Are you getting or not? Clear? And enthalpy of solution gives you to study the solubility concepts of the ionic solids. Okay? And enthalpy of hydration, I am coming back to this. It is the energy released or absorbed when 1 mole of anhydrous or partially hydrated salt undergo hydration by the addition of excess of water of crystallization. बहुत slow देख रहे हैं मेरा voice. Sana, can you hear me? Just I am thinking, can you all hear me? I think it is okay. Right. So, let's see here. So, what happened when copper sulfate is a solid? When water is absorbed, it is going to form hydrated copper sulfate. During this process, anhydrous form is converted into hydrated form, and put head voice will be clear. Okay, no problem, Sana. So, let's focus here. Here, the amount of energy that is called enthalpy of hydration of copper sulfate. Enthalpy of hydration of copper sulfate. And moving ahead, enthalpy of neutralization, definitely you can have a question based on this. Enthalpy of neutralization. Yes, it is the amount of energy, heat released when 1 mole of H acid and 1 equivalent of an acid and 1 equivalent of base is completely reacted in a dilute solution. This is what is called as enthalpy of solution. So far, I am always insisting never memorize the value, but here you have to memorize the value. It value is going to be minus 57.3, and please memorize this value. So H plus in the aqueous media and OH minus in the aqueous media gives rise water in the liquid, and it is going to be minus 57.3 kilojoule per mole, right? So this is what is called enthalpy of neutralization. मैं क्या बोलना चाहता हूँ here, very important thing, and for any strong acid you can see here H plus any strong acid and OH minus is given by any strong base, and you want to say here sodium hydroxide and here going to see HCl gives rise sodium chloride plus H2. I don't want to write the physical states because the board is going to be clumsy. So here it is shown that delta H is going to be minus 57.3 kilojoules. Let us use a different acid and a different base. So here I just want to say potassium hydroxide lena chahta hu, and I just want to take HNO3. Okay, you are going to see potassium nitrate and H2. इसका भी delta H is going to be minus 57.3. It is constant. So मैं क्या कहना चाहता हूँ आपको, जो भी a strong acid है and a strong base है, react करने तो you are going to give neutralization में okay, delta H is going to be minus 57.3 kilojoules. That is very important. So it is supposed to be 1 equivalent होना चाहिए and it is going to be 1 equivalent होना चाहिए. If it is a weak electrolyte, Sana, you attend the class, not a problem. Wear your headset, no problem. I am going to help you. Stay tuned, don't worry. So these are the fluctuations you can have. Don't worry. Here you can see here, my dear children, very important thing. What happens if sodium hydroxide is reacting with CH3 COOH is going to have CH3 COO Na plus H2O, and delta H value is going to be negative. Okay, so is it less than 57 or 57 or greater than 57? You tell me. It is supposed to be less than 57, less than 57.3 kilojoules. That's very important. Why? Because this is a weak acid. जो थोड़ा सा एनर्जी ये वीक एसिड में इस्तेमाल करने का कोशिश करता है आयनाइजेशन प्रोसेस के लिए. Okay, that's very important. And enthalpy of neutralization is equal to, okay, enthalpy of neutralization is equal to minus 57.3 into number of equivalents of the acid and base of the limiting reagent. You can use this. You can use this trick and you can calculate the numericals. Definitely you can do the best. And so far I think in the last decade, based on enthalpy of combustion, enthalpy of neutralization, questions 3-4 times is been asked, so that it is going to be a super important concept. Ready for that? Clear, my dear children? Any doubt? Please let us know, right? So focusing here, and Hess law of constant heat of summation. It's a super important thing. I want to do some questions based on that. So in this Hess law of constant heat of summation, you say reactant A is converted into D. So it is using the amount of heat is called Q in a direct step. Let us take some indirect steps also. If A gives rise to B and B gives rise to C and C gives rise to D. So here the heat is given Q1 and Q2 and it is going to be Q3. So he want to say that Hess law of constant heat of summation Q is equal to Q1, Q2, Q3. Here going to be Q1 plus Q2 plus Q3. Q1, Q2, Q3. So the heat of the reaction is the same whether the reaction takes place in a single step or the multiple steps. This is called as Hess law of constant heat of summation. He says that heat of a reaction of a direct step is equal to the heat of a reaction of the sum of the heat of the reactions of the indirect steps. Any doubt, my dear children? Please tell me if you have any doubt. Please let me know quickly. Take a snapshot. We'll do applications. We'll do applications carefully. Yes. Now you want to see this is a one application of the formation of carbon dioxide. Carbon plus oxygen gives rise to carbon dioxide. This is the root one, right? And carbon, it is converting into carbon dioxide, and this carbon dioxide is reacting with oxygen gives rise to carbon dioxide. That is a root 2. So the energy that is root 1 is equal to the energy that is required in the root 2. Both are going to be the same. Understand? It's very important. Let us do some questions based on this. You can see when the data, from the data, it is minus 393.5 from the data. You don't have to worry to memorize this. In the root 1, the value is going to be enthalpy of reaction is going to be minus 393.5. In the root 2, conversion of carbon to carbon monoxide minus 110.5 is released, and carbon monoxide to carbon dioxide it is going to be 283.0. You see the green and the orange values, and this value plus this value supposed to be equal to this value. This is what is called as Hess law of constant heat of summation. Are you getting or not? So these are the best example I can present you, and more examples are there. Stay tuned. Please like the session. Please like the session, everybody who are online, and let us do some question based on this. So using enthalpy of formation data in the enthalpy cycle, I want to give you here Fe2O3 का minus 824 दिया, and FeO का minus 266 is given, and NH3 का minus 46 is given, and it is given as H2O का minus 286 is given. So given the following data, calculate the enthalpy change of the reaction. Fe2O3 plus NH3 gives rise FeO plus H2O plus N2. Here इसका वैल्यू सबका वैल्यू मिला, N2 का वैल्यू दिया नहीं, मैं क्या आगे बढ़ना का मुश्किल हो रहा है. Can somebody give me the advice or suggestion to find the enthalpy of a reaction, enthalpy of nitrogen, enthalpy formation of a nitrogen? So मान के चलो it is an elemental state ना. So my dear children, enthalpy of formation for this nitrogen is being an elemental substance, इसका 0 ही होगा. Mind it, this is very important. So this is a simple step. You can go with the several steps. Let us follow the logic. Sana and Devanshu and Kaushik Kumar and everybody, please watch the magic here. Now in this, I just want to say, arrows must show the direction of the reaction according to the data given. Alright. And also in this case we have enthalpy formation of data, we are making a compounds from the elements. You can see here Fe2O3 NH3 gives rise FeO plus H2O. So this is what is called enthalpy of reaction. In this direction of the arrow mark is important, right? And also Fe can combine with oxygen, gives rise Fe2O3. N2 plus H2 gives rise H2 plus O2 gives rise H2O, and N2 plus H2 gives rise ammonia, right? So let us make a flow for this, and you can see from the given data Fe2O3 NH3 gives rise FeO plus H2O plus N2. For this delta H you have to calculate, but in this case in the root 1, in the root 2, Fe2O3 is converted into H2O, and here by Fe plus O2 gives rise Fe2O3. So this is Fe2O3, and here it is going to be O2, it is given minus 824 minus 46, and here N2 plus H2, O2 plus H2, H2O is going to be from the given values, and this sum and this sum is going to give you this, and that is given as the flow. You can see the flow. You can see the flow, my dear children. And Fe2O3 plus NH3 gives rise Fe H2O O2 plus N2 plus H2. So you can see the sum 3 into 824, 2 into 46. What is this? In this previous one, it is the negative values. Dear children, it is the negative values. Now it become a positive value. So if the reaction is reversed, the value of this is going to be the same. Delta H value will be same, magnitude will be same, but the sign is going to be opposite. Mind it. And Fe plus O2 gives rise N2 plus 3H2. Iska the other side is going to give you FeO plus H2 plus N2. And the sum of this, you can take this 3 into plus 824, 3 into plus 824, 2 into plus 46, 2 into plus 46, and sum of this 6 into minus 266 and 3 into minus 286. On doing so, you are going to get plus 110 is the answer for this question. 8 is going to be the very important. Definitely, if you do the questions at this level, na, you can do the best for your NEET examination. Believe me, you can do it. Okay. Now, moving ahead, और एक कर सकते हैं. One more, dear students, one more. Let us see here. Now, I want to give you one more data. So, acetaldehyde minus 1167 enthalpy formation ka. H2, it is going to be minus 286, and CH3, CH2OH, ethanol minus 1367. So, enthalpy of combustion data, this is enthalpy of combustion, not enthalpy of formation. Agar enthalpy of formation hoga to it is 0 hoga hydrogen ka, but enthalpy of combustion ka value diya. So, given the following data, and you are asked to calculate enthalpy change for this hydrogenation or reduction of acetaldehyde to give ethanol. You know, aldehydes on reduction gives rise alcohols. So, get ready for the future organic chemistry classes. Hai na? How many of you want me to start organic chemistry? You, Sana, Kaushik, and Abhinav, Devanshu, right? So, let's move ahead, right? So, this is the reaction and we are going to handle it. Simple. We are going to handle it. Okay? And for this we have two phases. So, route 1 and it is going to be route 2. Acetaldehyde hydrogenation gives rise to ethanol, right? And acetaldehyde is combusted to gives rise carbon dioxide and water, and ethanol is subjected for combustion in the carbon dioxide and water. You can see this combustion values. It is minus 1167 and minus 1367. It is going to be 1167, 1367. Got it? 1167, 1367. So that let us use this. Arrows must show the direction of the reaction according to the data. That is important. And in this case, we have enthalpy of combustion data. So we are burning the substances to make the carbon dioxide. You burn that to make this carbon dioxide. You burn this, you make this carbon dioxide. Hena? And let us see. Open, unveil. This is the one. Acetaldehyde plus hydrogen gives rise ethanol, and acetaldehyde combustion gives rise to 1167 minus 286, because hydrogen is also there, and it is going to be ethanol combustion gives rise 1367. So we have to enroute sum of this plus sum of this to gives rise this reaction, right better? Now let's see here. So acetaldehyde plus hydrogen, acetaldehyde combustion 1167, hydrogen combustion minus 286, and to form carbon dioxide and H2O. And the other side, carbon dioxide and H2O from acetaldehyde is going to be 1367. If ethanol gives rise carbon dioxide and H2O gives rise minus 1367, but I want to see the reverse side, it is going to be plus 1367. Now let us make this sum, and the sum is going to be here, you can say minus 1167 minus 286 plus 1367. On doing so, you are going to see the formation of 86 kilojoules. So you like this methodologies that we are presenting in the class, my dear children? You like this? Any doubt? Okay, so moving ahead, my dear children, let us see here. Enthalpy, the standard enthalpy change of neutralization, we did it. So enthalpy of neutralization or standard enthalpy of neutralization is the enthalpy change when one equivalent of an acid is completely neutralized by one equivalent of a base in the dilute solution. Its value is always constant. Its value is given as delta H is equal to minus 57.3 kilojoules. And how you are going to measure this? And that is measured by using a calorimeter. You like this? By using a calorimeter. So here just coffee cup calorimeter, so thermometer to measure delta T beta. And you have an insulated polystyrene cup with a lid, and 50 cm cube of HCl. 1 cm cube is equal to 1 milliliter, and 50 cm cube of sodium hydroxide, both added by volumetric pipette, and it is mixed. Hena? So when you do this, so you are going to see the mass of the solution is 100 grams, since water is the density 1.0 gram per cc. These are the noteworthy points when you are handling calorimetry in thermochemistry. And assume that all of the heat from the reaction is transferred to the solution. That is assumption. And assume that the heat capacity of the solution in the same water is 4.18 joule Kelvin inverse and gram inverse. So that is called heat capacity of thermometer, the calorimeter. It is given, it will be given in this question. Block C. Okay, hi, please like the session, bacha. Like the session, jaldi. Okay, now let us see here. Q is equal to mc delta T. So when you mix the sodium hydroxide and the HCl, you are going to see the formation of NaCl plus water, and a little bit of heat is also released. Because of the heat, the temperature is going to be elevated. You are going to see delta T. Delta T is equal to T2 minus T1. The difference is measured here. Difference is measured here. Understand? Right? Now, in this case, here the 4.18 is taken. Q is equal to mc delta T. So the mass of the total mass of the solution per gram, right? And you can see change in the temperature. Example, let us say 6.6. Let us say 6.6 degrees rise is seen. and specific heat capacity of the solution. So, heat capacity, it is given here, it is given here 4.18, and you can just plug it and you can calculate the thing. Jane Mehdi, thank you very much. It is a very important formula, and you can calculate this. You can calculate the enthalpy, plug every value, and you are going to get delta H is equal to. So, now Born-Haber cycle. Born-Haber cycle, right? What is a Born-Haber cycle? It is generally used to calculate the concepts called lattice energy. So, application of the Hess law is done by using the Born-Haber cycle. So, let us talk about lattice energy. So, what is the lattice energy? This lattice energy is nothing but the amount of heat liberated when 1 mole of ionic solid is formed from its constituent gaseous ions is called as lattice energy. Okay. So, here let us say sodium plus in the gaseous state and Cl minus in the gaseous state. It is going to give sodium chloride in the solid state, and delta H is let us say minus x kilojoules, 477 with something will come. This is what is called as a lattice energy. Then how do you calculate this lattice energy? You can't take this Na plus in the gaseous state and directly put in the calorimeter. You can't take Cl minus and put in the calorimeter, allow them to react. No, it is not possible. So, you cannot calculate lattice energy directly. Rather, you can calculate by using Born-Haber cycle. So, what is this Born-Haber cycle? I just want to show it is an application of Hess law of constant heat of summation. Dear children, let us say here Na, which is a solid, react with half Cl2, which is a gas, is converted into NaCl, which is a solid. So, for that we need a reaction enthalpy of formation. It is an enthalpy of formation Q. It is direct application of Hess law. Now, let us see, this is the root 1. Let us see the root 2. Na is going to be converted into Na in the gaseous state. This is what is called as enthalpy of sublimation. This is called enthalpy of sublimation or enthalpy of atomization, delta H atomization, right? And you can sublimation, you can say it is sublimation, enthalpy of sublimation. And you can see this is dissociated. So, that chlorine molecule is going to be converted into chlorine atom. So, this is what is called atomization, dissociation, atomization, that is called enthalpy of atomization. Okay. So, for 1 mole it is going to be enthalpy of atomization, but we are taking half mole now, it is divided by 2. And now Na is subjected for ionization to give rise Na plus in the gas. So, this is what is called ionization. So, this is called enthalpy of ionization, right? Now, this Cl is taken an electron, it gives rise Cl minus, this is called electron gain. Its magnitude is supposed to be negative, it is going to be electron gain enthalpy, delta H is equal to electron gain enthalpy. It is negative quantity, mind it. All are going to be positive quantity, right? Now, this chlorine minus in the gaseous state is available and Na plus in the gaseous state is available, and these two are joined together and it is going to give you sodium chloride solid, that is called as a lattice energy, that is called lattice energy. This is also a negative quantity. Okay, this is also a negative quantity. What I want to say here, my dear children, here delta Q is equal to delta H sublimation plus delta H atomization by 2, because you are taking half the mole, and plus enthalpy of ionization minus, because this is a negative quantity, enthalpy of electron gain minus, you are going to lattice energy is also the negative quantity, and this is the application of the Hess law of constant rate of summation. Dear children, here all the values will be given, you have to calculate lattice energy. And this is a super important question. You can connect to this NEET examination multiple choice question. If you answer this question, more than these difficulties you won't be having in your NEET examination. So Jain, Mehdi, hope you understood, Sana Rahman and Devanshu and Kaushik and Arnav. And stay tuned for such type of more important logic oriented sessions from the Infinity Land. We are done from my side. Please like the session, share with your friends and subscribe to NEET Infinity Land. Okay, thank you. Signing off, Suresh, Faculty of Chemistry from Infinity Land. Bye bye.